So this is the second part of my library management system application. Also I have named it as OneLibrary. Now we will see a small diagram uh, where it shows how all the features that we are going to implement for this application. So let's jump into it and see what we can achieve out of it. So as you can see, I have a small diagram open here. It's just a big picture of the whole application that we are building. So as you can see, there are three main applications in our whole application set. OneLibrary is the main application. Catalog is the second application that any online user can access to. And job is an application that does utility jobs like housekeeping jobs, data keeping jobs, data massaging, data pulling, all ETL kind of jobs. So this is the high level diagram for this. We will be focusing throughout this video on low level design of this same system. So let's just start with the OneLibrary first and point out what are the features that OneLibrary can offer. So let me just copy this. Let's keep this here. Okay. So before going further, we will list how we want to query the system. So the first feature, query, or maybe uh, how we want to use the system. So the first feature that it gives you is to list all the books in the library. So this is my first feature that it should cater. So this is quite easy. So what we are going to do for this feature, we need as you already know, we're just going to query the database using a single query, and we will be getting all the books. That's pretty simple, right? Yeah. So before going further, let's see how we can do that. Let me grab a icon for DB. This is good. So we can keep it here. And this one. So that being said, we will be, or maybe I can use this one. This looks nice. But this is from AWS, right? Okay, that's here. Let's move this aside because there are some other things that coming in. Okay, so the easiest way to do this is to directly connect this to this database, and we will be querying. We will be using one single query to get all the books that we have into our database, and most primarily we are using an SQL server here for storing the books server. Okay, so let's keep that here. But you see, in a very scalable application, in a distributed application, there can be multiple users who are accessing your uh, application, and they are like hitting the database very frequently. And most of the time it can happen that they are accessing the similar data. So we don't want to overload the SQL server or any database with similar queries, because it's not performant each time you have to go to the server and get the data. In order to fix that, there is a way we cache the data in between our SQL server and our application so that we can serve the data much faster. So there are multiple ways to implement caching. We can cache the data in memory, like in the client side itself, or maybe the server side itself. But in most scenario in distributed system, it is ideal to use a distributed caching server that can serve all the cache for all the instances of your application. And it's also like a fault tolerant and reliable, as it's managed by multiple instances of its own. It has on its own replicas. So we can, among all of them, Redis is the most popular one. Popular caching soft caching software, where it can be used to cache the data. So in what would happen here is that once you hit the get all book query, or maybe the function, it will go to, at first it will check in this Redis cache whether for a given parameters does the data exist. If it exists, it will immediately respond back to the server. Otherwise, it will go to the SQL server and get the data. And once it get the data, it will come back to the Redis cache. Redis cache will keep that data with the parameters as key and then return the data back to the server. So this is one simple design that I can think of, and that works most of the time. But we can also come up with more diligent and efficient design. You can write about it in the comment section if you have something. Okay, for timing, I can cater the list of all books using this diagram. Let's move to the next one and see how we can do the other stuff. Okay, so the next feature I have is to add a book. So let's just copy this. Okay, so adding a book is also quite simple. You just get the payload and just hit the database, and it should be saved. Okay, this is nice. We are saving it, but the problem arises when someone has hold database lock, and you are trying to add something, and it fails. So sometimes it's ideal to have a lock before like writing onto the database, so that you do not like step over on the other things. So and also we can use Redis cache to like to cache the post data, so that whenever you have a uh, add request in the future, we can respond back to the client much faster, without waiting for the server. So we can do this like this one. Here it caching. Let me label this as well. Cache db, and this is post cache. Okay, perfect. Now Okay. So we are saying that we are saving a book, we are adding a book, and it goes to this Redis cache. And once it is cached, or whenever we try to add a new one, it immediately responds you back with the response, and send that back and sends the request to the SQL server. So this is being said, we can also do one thing, like we can implement a distributed lock here before going further. Hmm. Let me do this. Find something. Let's use this. Okay, so this is a distributed lock. I know most of the time I have seen uh, people like to use distributed locks on update queries only. But yeah, there can be some situations where while adding you have some issues. So I like to keep the distributed lock while adding as well. And later when later we will be extending this diagram uh, to see how it connects to the message queue. But for now I'm just keeping this simple. And the next feature I'm having is to update the books. So updating book is also very similar to the add book, uh, kind of. Uh, yeah, almost similar. Uh, so what I can do is just update this one. Update book. Just that in the request body you should also have an ID. In add we don't have an ID, but in update we would be having an ID. And these are the two features that I want to implement for now. This is the major feature that this system can do. The next big feature that OneLibrary can do is to issue a book for a student. So I will be covering that in the next video. This video is already too long, but to summarize, this is the whole picture of our application. There are three applications: OneLibrary, Catalog, and Job, and they are all disconnected softwares, and they all will be working on a different servers. So we will be continuing on our design in the next video. Thank you for watching.